Hello and welcome to a very special at-home coronavirus quarantine episode of Mr. Viola's physics classroom. Today, we're going to look at flying things and go over how to do those problems. So we start first with a circus clown that's shot out of a horizontal cannon that is situated 45 meters above the ground. If he leaves the cannon with a speed of 30 meters per second, how far away should the landing cushion be placed? So the first thing we want to look at is our 11 variables. X, XO, Y and YO, VXO and VX, VYO and VY, AX, AY, and T. So we have 11 variables that we could possibly solve for, or that may have been given to us. The obvious ones that we got in this are that it's situated 45 meters above the ground. So initially I'm starting in a vertical position of 45 meters. It also tells me it leaves the cannon with a speed of 30 meters per second. The key word here is horizontal cannon. So VXO is my horizontal initial velocity, and that's 30 meters per second. From this point, I need to start making assumptions or taking things that I know and putting those in. I know that the horizontal acceleration is always 0 meters per second squared. I know that the vertical acceleration is always negative 9.8 meters per second squared. I know from the problem that we want to find out how far I'm going to shoot the clown and where the cushion needs to be placed, so we can say horizontally I'm starting from 0 meters. I know that when he lands, he's going to be on the ground because that's where the cushion's going to be, so my final vertical position would be 0 meters as well. The tricky one is VYO, your initial vertical velocity, because it's not obvious, but a horizontal cannon would have no vertical component to its velocity. So that's 0 meters per second as well. Now the last one I know is actually the horizontal final velocity. Because I'm not accelerating, I know that that still has to be 30 meters per second. So you can see I actually filled in quite a bit of the variables here just from very little information being given. So we want to know how far away should the landing cushion be placed. How far away would be a horizontal position? So I'm looking for X. And what you should have found, and I'm sure most of you did, is that you can't solve for X without knowing T. The nice part about time is that you can use either Y or X values to solve for it. It's going to be the same regardless. You're going to fall and hit the ground the same vertically as you did horizontally. The time is a go-between. So we want to start with this equation. And we know it's this equation that we want to use because I have all the variables except for the time. So when I start to fill in what I know, I get 0 equals 45, VYO is 0, and then 1/2 negative 9.8 t squared. So we move the negative 45 over here. 1/2 of negative 9.8 is negative 4.9 t squared. When I divide this out and I take the square root, I should end up with a t value of 3.03 seconds. So the clown is going to be in the air for 3.03 seconds. I can use this value now to solve for X. And I use the same equation that I just used, but this time with my X values, my horizontal values. So my final position is equal to 0 plus 30 multiplied by 3.03 plus 1/2 0 times 3.03 squared. Now this completely cancels out. It becomes 0. So X breaks down to just 30 multiplied by 3.03, where X has a value of 90.9 meters. So our final answer for this is that the landing cushion should be placed 90.9 meters away from where the clown is shot. The second part of that question is with what speed will the clown hit the cushion? So now what I'm looking for, first we want to solve for Vy, because what I have, if we draw it out, is a cannon that's going to shoot my clown in this direction, and he's going to land on the cushion. But he's not going to land straight. He's going to land at an angle. And so what that angle looks like is a vector quantity, which is 30 meters per second going horizontal. Whatever I get for Vy going vertically. And then this number right here, the hypotenuse of this triangle, is going to be his final velocity when he hits the cushion. So we need to look at what we can do to solve for Vy. The easiest one to do is this right here, where we have Vy is equal to 0 plus negative 9.8 times 3.03. So this should come out to about 30 meters per second. In this case, negative 30. And then you would plug it in here, and you can do the Pythagorean theorem to solve for the hypotenuse. So that would be my final velocity, is whatever I get for the hypotenuse of this triangle. And that's how you would finish up number 1. For number 2, I have an airplane that's flying at a speed of 50 meters per second, and it's attempting to drop a life raft to a ship in distress. If the plane's flying at an altitude of 80 meters, how far away from the ship should they release the raft? I would start this exactly the same way that we just did number 1. So x, xo, y, yo, vxo and vx, vyo and vy, ax, ay, and t. Start with your 11 variables, and from there we can see what we know, what we don't know, and what we're looking for. So we know that an airplane's flying at a speed of 50 meters per second. Again, that's our VXO. We're flying horizontally. Presumably you're not flying in a vertical drop or going up. And you're trying to drop a life raft. So we're flying at an altitude of 80 meters. Our YO is 80 meters. And how far away from the ship should they release the raft? I don't know my horizontal final position. This is what I'm looking for, is X. My initial position is 0, and my final vertical position is 0. What I do know is that my final horizontal velocity is also 50 meters per second. I know that I have no initial vertical velocity. I know that my acceleration in the horizontal direction is 0 meters per second squared. And my vertical acceleration is negative 9.8 meters per second squared. Again, I don't know my time. We're going to do a very similar procedure here. I can start with y equals yo plus vyot plus 1/2 ayt squared. So 0 equals 80 plus 0t. Once again, this t cancels out. 1/2 negative 9.8 t squared. So negative 80 equals negative 4.9 t squared. If I divide this, I end up with a time. So 80, negative signs go away. 80 divided by 4.9 should give me approximately just over 16. I end up with 4.04 seconds as my time. And then again, we move to our x equation. And we end up with x equals 0 plus 50 times 4.04. And then as we know, the ax is going to be 0. This is going to fall off anyways. So my final position, 50 times 4.04, is about 202 meters. So the airplane needs to let that go, that raft go, about 202 meters away from the ship. As we move to number 3, it becomes a little bit different. This time we're looking for a speed. So for number 3, once again, we're going to put down our variables. Y, AY, AX, and T. Always start by listing out your variables. It will let you know what you have, what you're looking for, and maybe what's not important to the problem. So before we even look at the problem, we know AX is always 0. AY is going to be negative 9.8. And so we read that Harry stands on a balcony 20 meters off the ground. So that means that I'm starting at an initial position of 20 meters. He wants to jump off and land in a pool which is 15 meters from the base of the building. I'm starting in a position of 0, and I'm going to land, hopefully, 15 meters away. With what horizontal speed will he need to jump in order to make it into the pool? So what I'm looking for is horizontal speed, initial horizontal velocity. I don't know my final horizontal velocity. I know that I have 0 vertical velocity, and I don't know my time. So I do know, though, that I'm going to end up at 0 meters as a height at the bottom of the pool. So we're looking for our VXO. Again, you'll notice we don't have a time. That's okay. So maybe we can do it the same way we did it before. If I need to solve for time, let's at least start here. We have a y value of 0, an initial y value of 20 meters, an initial vertical velocity of 0, and again, negative 9.8 t squared. So negative 20 equals negative 4.9 t squared. T ends up being 20, again, these become positives. 20 divided by 5 is roughly 4. This ends up being 2.02 seconds when you do the math. So now I have a time of 2.2 seconds. This time I'm not looking for x. I already have x. I'm looking for VXO, but maybe we can use the same equation. So VXOT plus 1/2 AXT squared. Again, this becomes 0. So I have 15 equals 0 plus VXO multiplied by 2.02. So divide both sides by 2.02, and VXO ends up right around 7.5 meters per second. So we leave with a horizontal speed of 7.5 meters per second. You will make it into the pool, or I guess Harry will. Converting it to miles per hour, I think you can all do. With what speed will he hit the water? Well, we know VXO is 7.5 meters per second. We need to find VYO. We can do that, or excuse me, VY. We can do that very simply like we did last time. 0 plus negative 9.8 multiplied by 2.02. So we're looking at almost 20, or negative 20 meters per second. Again, Pythagorean theorem right here, find the hypotenuse. And then the last part, at what angle will he hit the water? What we're looking for is this angle right here. And that would require a little bit of trigonometry. I would suggest inverse tangent of opposite divided by adjacent, which would be 20 over 7.5. And that will give us the angle with which he enters the water. And finally, for number 4, we have a deer hunter shooting a rifle horizontally at a speed of 5 meters. If the bullet leaves the barrel at 800 meters per second, how far away will the bullet land? So, once again, every time we list down our variables. Y, AX, and T. And we can fill in what we know, what we don't know, and what we're looking for. So you're at a horizontal height of 5 meters. I start there. We wonder how far away it will land, which means when it lands, it's at 0 meters. We started at 0 meters horizontally. I'm looking for how far away it's going to be horizontally at the end. It has 800 meters per second of initial velocity. It has no vertical velocity, a negative 9.8 meter per second squared acceleration, 0 meter per second squared horizontally, and I don't know the time that it's in the air for. So just like the previous 3, we'll start with the same way to solve time. And we look at 0 equals 5 plus 0 times t plus 1/2 of negative 9.8 t squared. So I get 5 equals negative 4.9 t squared. T is roughly, negative 5 is roughly 1.01 seconds. And we divide that out. So the bullet's going to be in the air for 1.01 seconds. X equals XO plus VXOT, 1/2 AX T squared. I feel like we've done this enough now where you know that's going to be 0. X equals 0 plus 800 times 1.01. So the distance is roughly 808 meters. The interesting part of this problem is that what we broke that down to is X equals VXO times T. And really it's delta X, which should look very familiar because if I rearrange that, it is the velocity equation that we've been doing since September. So this should look very familiar. You have this extra stuff, it ends up not mattering in most of our problems because AX is almost always 0. If you have more questions or concerns, please let me know. This will be helpful going into your next assignment tomorrow night. Thank you and have a great day.